Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Winelect, and today we're going to be looking at what is a service mesh, when and why you would want to use one of these, and then how to go about choosing to use a service mesh. Today, we're going to be looking at what a service mesh is, and we're going to try to figure out what a service mesh does, and we're going to look at some of the architectural implications that it has on applications, in particular ones that relate to microservices. We're not going to do any technical demos in this particular video because a lot of the content here is pretty in-depth and it's pretty broad too. So I decided to take an entire video to understand what a service mesh is and then talk through when to use it, why to use it, and then hopefully give some guidance on choosing to use a service mesh. I'm not going to do any demonstrations of any particular service meshes. We'll be looking at those over the next few weeks as we look at some of ways that you can use service mesh implementations on Azure Kubernetes services. Before we get into the details of what a service mesh is and why you would want to use one, it would be good to kind of understand what the intent behind a service mesh is. What is it really trying to solve? A service mesh at its core is a software or infrastructure architectural pattern that is used to facilitate service-to-service communications. Now, understanding this critical distinction here between it and other kinds of service-oriented infrastructures is that it is oriented towards service-to-service communications. And this will have a lot of implications when we look at some of the architectures later on, what it's intended to be used for. And when we look at service-to-service communications, we're trying to figure out a way to manage a lot of complexity that comes along with this. And as we walk through this, I think you'll begin to see how having a lot of small microservices can create a lot of additional complexities within the context of an application whenever you start to actually use microservices. But at the heart of what a service mesh does, it's trying to do a couple of things. It's trying to improve communications between services by doing a lot of different things related to making routing easier to do, by making it easier to discover where services exist. And it provides a lot of services to services that will enable them to figure out where a particular instance of a different kind of service might be. So one service can call a second service and figure out exactly where that service is and then call it and then get back some kind of information or get back some kind of result for a process that is expecting it to run. Second, it improves observability into the service-to-service communications, because what a service mesh will do is give you traceability across an entire infrastructure. So you can look at a single call that is put into a service mesh and figure out what node originally received that request and then follow it all the way through the entire stack to figure out where it came out and what it actually did along the way. And that's what the traceability and the logging that a service mesh provides is intended to enable you to see. And it will give you things like telemetry data, the metrics about how latency is, about how long it's taking to process particular requests. It'll give you percentages on CPU and memory and other things like that. But it's principally designed to figure out the nature of where services are processing things and how the flow of information is going through a particular set of services. It also improves security, because what a service mesh provides is the ability to have security between all of the nodes inside of a particular service mesh. Now, when I'm talking about a node, I'm talking about a given service. Now, what this enables you to do then is focus your service on not having to worry about providing a security embedded in the service. Rather, it delegates that to the infrastructure that it's running on. So it provides things like encrypted channels between service calls. It makes sure that the authorization and authentication is present between all of those services that are being called. That functionality is then baked into the infrastructure, and it's not something that has to be handled by every instance of the service. So it allows you to have a lot of different services that can be written in different languages even, and the requests then get wrapped up in encryption encryption and an authentication and authorization, and then get decoded on the other end, whoever's receiving the request, and making sure that the authorization, authentication, and encryption are all there across the service mesh. And lastly, it's intended to help improve fault tolerance and testing. And these fault tolerances come by way of the service mesh providing the ability to scale and do tests when it comes to things like canary tests to make sure that there's A/B environments to do rollovers. It also does things like self-healing and load balancing. It can also detect bad services when they might be failing and then redirect traffic to healthy nodes, and a lot of those kinds of things that we kind of come to expect from most service architectures and most platforms that are running those service architectures as well. So when we talk about a service mesh, it's critical to understand the architectural components of it because it has implications on how it accomplishes all of those things that we just talked about when concerning communication, security, and so on. And it'll also give you a better idea about how applications are packaged for service mesh when you understand the more general architecture that is pretty much deployed by all implementations of service meshes. So a service mesh will almost always have a control plane, and the control plane is the part of a service mesh that is responsible for managing the settings of a service mesh. It's also responsible for doing things like discoverability and things like that. So whenever a particular service goes to find another service, it can go get that information and then figure out where it is so that that request gets sent to the appropriate endpoint, wherever that might be. And it gets that information by way of something else, but it ultimately comes from the control plane. The next piece is the data plane. And the data plane is where all of your application instances are running. So any particular service of your overall application would be running the data plane. And this is where your container would run. So your application or your service gets packaged up in a container and it gets deployed into the service mesh data plane. Now, it's not the only thing that comes along with the service. Most all of these will come with something called a sidecar proxy. And the sidecar proxy is really the secret sauce of a service mesh. A proxy in this case, in the case of a service mesh, is responsible for interacting with the service mesh itself and all of the other components that support it. So it's responsible for interacting with something like the data plane. So the proxy will get commands from the data plane in order to set something about that proxy. And the control plane itself interacts with a cluster admin or developer that's setting all that up, and the cluster admin will tell some kind of setting into the control plane, and then that will then update the proxies that are associated with all of your service implementations. And then the proxy is also responsible for brokering all the communication between each instance of the service. So this is the piece that will then take all the requests from one service, wrap it up inside of some kind of encryption layer, and then it will also provide some authentication and authorization to that request, and then it will send it over the wire to another instance of a service, and that other service will receive that request. It will unbundle the encryption and then check the authentication and authorization against the control plane, and then it will, after it's done all that, if everything checks out, it will then process that request according to the code in your application. So that proxy is the piece that brokers the communication between not only the application users, but each of the service to service calls that are made inside of the service mesh as well. So it's an important piece that makes the service mesh more or less work. And the proxy is also responsible for reporting telemetry out of the particular instance of a service back to some kind of monitoring and logging solution so that you can get all of that good data that you want to be able to use to trace through your service mesh. You want to be able to track a request from beginning to end all the way through the service mesh, and the proxy, because it's actually wrapping up that request in some kind of additional layers. It can do that by way of some kind of cookie injection or some kind of UUID that it tags to that particular request that gets passed along to every service call that ends up making along a given chain, so that that information gets put into some kind of logging system so that you can trace it through the entire stack whenever a given request is made. And these kinds of features are what are provided by that proxy. And the decoupling of your application from that proxy is really what allows your application to exist in its own little world. And it doesn't have to worry about things like the encryption. It doesn't have to worry about things like the authentication and authorization. It simply just focuses on the code aspects of it and delegates all that responsibility to the service mesh to handle. So this really gives you the ability to not have to bake that into every application that you write or every application component you write. You can let the service mesh handle that and then let your actual service be rather thin. So that's one of the trade-offs for using a service mesh. Now that we've looked at the architecture of a service mesh, I want to look at a couple of application architectures that one might think about using a service mesh for, and ones that you might not use a service mesh for. So consider the diagram that we have up on the slide here. This is a typical interior application. Now, some interior applications are what we might call a monolith, and a service mesh is certainly not going to apply there. This kind of implementation here is a set of APIs where you have broken up the APIs into a bunch of small stateless APIs that don't have any kind of state managed by them. So you can scale those independently. You can do a lot of vertical and horizontal scaling with these APIs, and they can have multiple instances of those so that you can have any request, process any incoming request. And this is a good approach. And it is sometimes called microservices by those who implement these kinds of services. A lot of times what people are doing is they're taking their older monolithic applications and taking those and breaking them up into smaller chunks. They're taking the APIs provided by the monolith and then breaking up into smaller bite-sized chunks and their APIs, and then removing the state management from them, and then putting those into some kind of environment so they can scale those APIs independently of one another. And they're calling it microservices. And in some ways that is a microservice, and I don't want to downplay it as it not being a microservice. Microservice has very little to do with the kind of architecture that it actually ends up being used in. It's more about how the services are written. That is that statelessness and that the ability to scale horizontally very easily and those kinds of things. But it's not so much a fully realized microservice architecture. Now, a fully realized microservice architecture looks a little bit different than what we have here. Fundamentally, though, when you break up APIs into these smaller bite-sized chunks and then have them scale independently of one another, you have still an interior application. You still have that three-layer type application where you have a UI, you have a service layer, and then you have a database layer. It's not a very complex in terms of a bunch of services calling other services. And remember, when we introduced service mesh, we were talking about service to service communication. So in this kind of architecture, we're not going to really see a lot of service to service communication. We're basically going to be seeing a lot of incoming requests from a UI layer, which is going to be running in a browser. What's going to be running inside of the actual compute that's going to be running the APIs is a bunch of services that are handling those requests that are then going to be going out and making requests against a database that isn't a part of that compute that is handling those requests inside of those services. So what you end up with is a rather thin layer of APIs that are receiving requests and then going out to a database, then getting some data out, processing that data, and then returning the results back to the client. This is not an instance where you would want to use a service mesh because it really doesn't give you anything, because you don't really have a lot of that service to service communication going on here. So this is one of those architectural patterns where a service mesh really isn't going to give you any benefit because you're not really getting any kind of service to service communication or anything like that in terms of what you need for discoverability, security, and so on. Most of the security is actually going to be brokered by some kind of firewall through SSL termination or something along those lines. And the database communication is going to be brokered by way of the database driver in the application, and it's going to be encrypted and going down into the database. So there's not a need for service to service communication to be encrypted and authorization and authentication or anything along those lines. So this is not one of those instances where you would have that kind of architecture implemented. Now, this slide, what we're seeing here is a representation of a microservice architecture that is what we might call a more fully realized microservice architecture. And with microservices, you can have that API layer where we're breaking up in things into smaller chunks. And that is a good thing to do. But with microservices, what you end up with typically when you start breaking things up is a lot of small services that are calling one another. And so the actual UI of an application doesn't always interact with every service that is available through a given API. In fact, what that API might do is get a request, and then it takes that request and then farms out parts of it to other parts of the application suite that are inside of the same compute. And so in this case, our compute is represented by this box here, where everything is running on a compute cluster that is a bunch of services that are receiving requests from external users through a UI. And then from that request, it's actually making a bunch of other requests to other services that are running inside of the same suite of services. So you end up with a bunch of services calling services, calling services, calling services. And you end up with a very complex web of networking and a very complex web of services that are all trying to talk to one another. And this kind of architecture, while it really does a good job of supporting the very granular approach to microservices and making sure that they are doing one thing only and they are doing all those good things that microservices are supposed to do, it does exponentially increase the complexity of the communications between services. Like on the previous slide, we saw where the communication was fairly linear. Here, it's not linear at all. It's actually a very complex network of communication that has to be managed somehow. And so the traceability in this case is very difficult. So you don't know in per se when a particular service is going to call one instance of a service, and then on the next request it might call a completely different one. So you can see how in this case communication between services is very complicated and very hard to manage. So this is one of those cases where you would want to put some kind of governance or some kind of manageability around this so that you can make managing a bunch of services like this and the communications that come from it easier. And this would be the canonical case for using a service mesh. And this would be one of those where if you're doing services like this, you would almost always want to use a service mesh to handle it. With the last two slides, we looked at two kind of extremes of different implementations of microservices. One was the thin API implementation that is essentially an interior application that uses microservices for the APIs. And the other one where you have a fully realized microservice architecture where you have services calling services, calling services. But in reality, most applications end up looking something like what we have here, where we have a API layer that might be thin in some cases, but then at the same time, we have some microservices that are independent of that, that are calling one another, that are receiving requests from an API layer of sort as well. And these could be things like workflow engines, and they could be other things that receive requests, process data. It could be a lot of different kinds of implementations, whatever that might be, coming out of that particular API into those services that are running over there. So you end up with essentially a hybrid of an interior application and a fully realized microservice architecture. And in this case, you're kind of sitting on the fence going, well, do I really need a service mesh or do I not need a service mesh? Because my service implementation that are running in those microservice architecture that where you have services calling services isn't real big. It's only a few services. So the exponential growth of that is still rather easy to manage. And I don't need a lot of additional complexity on top of that that is added by a service mesh. And you might be kind of thinking about using a service mesh, but you're not 100% sure because it's not exactly clear where you might fall on the spectrum between the interior application and the fully realized microservice architecture. And the truth is, in this case, it's not clear if you should use a service mesh or not. The thing about a service mesh, though, is it's not something that you can easily implement and you can just turn it on at a later date. And because if you start down the path of not using one, going back and retrofitting everything to use it becomes a more difficult task to do, and it requires a lot of refactoring of things. So if you're thinking about going down the service mesh route, it's one of those things that you might want to think about up front whenever you're looking at a given application. If you're greenfield and you're starting complete from scratch, it might be a good idea to go ahead and implement a service mesh, even if you only start with a few services and then you implement something that's that more full realized service mesh architecture. If you're trying to refactor an application that's an old in-tier application into something that looks like the first one, then you might not want to consider using a service mesh. But if you're trying to update an application and it's taking on new functionality, and some of that new functionality begins to look like a microservice architecture that is fully realized versus an in-tier application, you end up with something that's a hybrid, then it might also be conducive to think about using a service mesh in this case as well. So I'm going to mark this one as an it depends type explanation, depending on how complex those service to service communications get. And this is something that you might have to put a lot of thought into whenever you go into making this decision process. Now, having said that, like I said, you can go back and retroactively apply it, but it's a lot more work to do it after the fact than it is to do it up front whenever you're thinking about moving into a service mesh and using one of those to help facilitate communications between your services. When we look at a service mesh, it's critical to also understand what a service mesh isn't going to do for you. A service mesh is not a magic wand that's going to make services easier to manage or going to make microservices all of a sudden a super easy thing to do. In fact, it might have some additional problems that you have to solve when you implement it. But the trade-offs that it gives you are some of the benefits that we talked about earlier in the deck whenever we looked at some of the things that it's trying to accomplish. So what does a service mesh not do for you? One, it does not reduce your complexity. In fact, it might increase your complexity. If you go back to the slide where we saw the architecture of a given service mesh, where we had the actual services running with an additional sidecar proxy, that's one of the additional complexities that it adds to it. It also requires that you set up things like private key infrastructure so that you can get encryption between all of the pieces in your service mesh that you're going to have. It also requires that you set up some kind of authentication and authorization between those services. Now, typically that might be done with certificates. So they use certificate-based authentication between the service calls, and that still requires PKI to be set up. It also requires that you set up the logging components that go along with it so you can get all the monitoring and the logging out of those particular service instances that are running in your service mesh. It adds a lot of additional complexity to the environment simply because it's doing that for you to give you that communication, to give you that the security, to give you that logging in a more infrastructure-based approach to that. And so all of that combined adds a lot of additional complexity to your environment. So if that complexity scares you, or you might not need that level of complexity, a service mesh might not be the thing to use for you. However, having said that, that is no reason not to use it either, because those are certainly good things to add to an environment, especially if you don't want to bake them into the actual code that's handling the requests that are coming into your environment. Second, it's not going to improve your performance at all either. A service mesh adds a lot of overhead to your environment, and it adds overhead to every request that is made. So you have requests coming in, you have requests going out of services, and it requires that those requests get encapsulated in encryption. It requires that they get the kind of authentication and authorization. It requires that there be logging and other types of telemetry coming out of that environment. And so there are performance implications for all of that. And by adding a sidecar proxy to every instance of your service, you're adding additional overhead to each instance of your service, and adding an additional hop on the request chain of any given service. So the improvements that it's adding are more of the non-functional requirements of a system and the inter-process communication for security and things like that. But it's not going to be something that you can put in play that's going to improve your performance of your environment. In fact, it might slow your environment down because it is adding quite a bit of overhead to every request and to the environment as a whole. And the last thing that it's going to do is reduce management overhead, because a service mesh introduces a lot of additional complexities to your environment. It gives you a lot more knobs and dials that you need to turn and switches that you need to manage so that the environment is both set up correctly and that it is doing what you want it to do. It gives you a lot more control over the environment, gives you a lot more fine-grained control over the kinds of services that you'll be running in that environment, but it isn't going to reduce any of the management of that environment at all. In fact, it might actually increase the management overhead. It might increase the amount of time that you spend configuring that environment as well. So if you think about something like Kubernetes running something like a service mesh like Istio, you now have Kubernetes to manage along with Istio, and you have all of the complexities that both of those bring to the table in addition to your services that are running. So again, service meshes are a great tool for doing a specific task that is managing services at scale, providing a lot of value added to those services, but it comes at a cost. And that is really what this slide is trying to pick up on, is those particular caveats that you might want to think about whenever you're considering using a service mesh. So choosing to use a service mesh or not to use a service mesh is not a simple question that can be answered as a black and white kind of question. It's not either yes or no. There's a lot of gray there. The canonical use case, as we saw, is that services calling services kind of architecture that is a fully realized microservice architecture, but very few applications actually use that style of architecture unless they're greenfield and have been written in the last, say, 5 or 10 years. Most applications are going to take on that in-tier application approach, which has traditionally been the way apps have been written for the last 20 or 30 years. And you might have some sidecar or some side services that are being a part of that application. So it ends up looking like that third application architecture. And in my experience, that has been the reality for most applications I've looked at in the last, say, 5 or 6 years, when I've been doing a lot of consulting with companies that do have applications that are implementing microservices of some kind. So the choosing to use a service mesh is really going to take the factors that are considerations for that, which are A, what does my application look like, and B, what are the complexities that a service mesh are adding to my environment. It has to weigh those added complexities against the benefit that I'm going to get from it. And in many cases, the benefit might not outweigh the additional complexity. And in some cases, the benefit might drastically outweigh the complexity it adds to the environment. The best thing to do, though, is to make sure that you figure out this up front before you actually go down the road of trying to add in a service mesh into an environment. It's much easier to do it up front whenever you're going to deploy an application into a containerized environment such as Kubernetes than it is to do it in retrospect, because once it's already out there, trying to go back and do that after the fact is much harder to do it than trying to do it up front whenever you're trying to do it whenever you're going to Kubernetes rather than when you're already on Kubernetes. So over the next few weeks, we're going to be looking at how to install different kinds of service meshes with Azure Kubernetes services. We're going to look at Linkerd, we're going to look at Istio, and then we're going to look at Consul as well. And these are kind of the three big ones that most folks use. Istio is probably the most popular one, but I do want to address Consul and Linkerd because they're simpler to implement than Istio is, and they might be better for smaller applications. Istio might be better for larger deployments, depending on whatever that might be. But we'll look at each one of those and talk through the advantages and disadvantages of those, and look at them in relationship to Azure Kubernetes services. So looking forward to doing this little mini series on service mesh implementations on Azure with Azure Kubernetes services.
If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.